Hi class, welcome to this new video still on Laplace transform. In this video, we would like to share with you two properties of the Laplace transform. The first property will be the linearity of the Laplace transform. Let's have a look at that. Okay, let's consider A and B be two constant, two number, and then let's consider the fact that the f of s is the Laplace transform of f of t, and then g of s is the Laplace transform of g of t. If this is the case, then we can have that the Laplace transform of a ft plus b gt equals to a Laplace transform of f of t plus b Laplace transform of g of t, which can also be equal to a fs plus b gs. Now, this can easily be proven if we apply the integral of Laplace transform of a ft plus b gt, right, equal to the integral of 0 to infinity of a ft plus b gt e minus t dt, which is equals to, if I split them out, I have a 0 to infinity of f of t es minus t dt plus b 0 to infinity integral of g of t e minus st dt. So what can you realize? You realize that this is the integral of the Laplace transform of f and this of g. So this is equals to a times Laplace transform of f of t, and this b times Laplace transform of g of t, right? So we just saw that the Laplace transform conserves the linearity property. Now, in practical, let's have a practice. Find the Laplace transform of t squared minus e 2t plus sine 2t. Okay, how will you find the Laplace transform of this? We realize that the Laplace transform of this will be simply equal to the sum of the Laplace transform of each of the function because of the linearity property, meaning that the Laplace transform conserves the additive property. So this will be equal to, right, Laplace transform of t squared minus Laplace transform of e 2t plus Laplace transform of sine 2t. So having this and using the Laplace transform table, we can easily find the Laplace transform of this. This gives me 2 over s3 minus, right, the exponential will give me 1 over s minus 2, and the Laplace transform of sine 2b will give me 2 over x squared plus 2 squared plus 4. So this will be the answer of the Laplace transform of this function. The second property we have to look to give a close look is what we call the first shift theorem. The first shift theorem. So what does the first shift theorem say? It says that if we have that Laplace transform of f of t equals to fs exist, and we have that s is superior to a, superior to 0, then the Laplace transform of f of t times exponential et equal to fs minus a. So this is very important. Now, remember that when we had before the definition of the Laplace transform, we defined the Laplace transform of a function f of t right, being equal to this, right? Now, the first shift theorem says that if you are finding the Laplace transform of a function f of t being multiplied by exponential et, it will be equal to f of s minus a. You can see here that when you find the Laplace transform of f of t only, you have f of s. So the first shift theorem tells you that the Laplace transform of a function of time being multiplied by exponential at is the same as finding the Laplace transform of a function of time, but by substituting s by s minus a. Okay, let's have a look on this example. It says that 1. Find the Laplace transform of EAT. That's the first question. Now, when we diagnose this, we realize that this can be written as 1 times EAT. So my function of time f of t here is 1, and then and then I know that the Laplace transform of 1, the Laplace transform of 1 is what? Is 1 over s. Therefore, the Laplace transform then of this EAT will be equal to what? Instead of 1 over s, it will be equal to 1 over s minus a, because I substitute the s in the Laplace transform by s minus a. I hope you're getting it. Secondly, find the Laplace transform of t exponential et. So, what is the Laplace transform of t? The Laplace transform of t is what? Is 1 over t squared, right? The Laplace transform of t is 1 over x squared. So, Laplace transform of t is 1 over s squared. Solving this using the first theorem will be 1 over s minus a squared. 1 over s minus a squared, because I'll substitute the s by the s minus a from this theorem. Looking at the last example, find the Laplace transform of sine 2t exponential 2t. Okay, what is the Laplace transform of sine 2t? Laplace transform of sine 2t equal to 2 plus s squared plus 4, right? It means I have now to substitute here this s by s minus a, and my a here is what? Is 2. So this is equal to 2 divided by s minus 2 squared plus 4. So this is how you apply the first shift theorem as well. In this video, we saw two major properties of the Laplace transform, the linearity and the first shift theorem. And we hope that with the example that we did together, you'll be able to grasp the content of this video. Thank you very much. Bye.